405, we are proving the diagonals of a rhombus are perpendicular. Now we've got a rhombus, we've got RHOM here, and we're going to actually show that the diagonals are perpendicular, specifically like right around here, by focusing on like these two triangles, triangle RBH and triangle RBM. And we can do that with side, side, side. So let's make a list. We can list off and say that RB is perpendicular, is congruent to itself. That's the first S in those two triangles being congruent. Then we can say that RH, so RH and RM are congruent because, it's a rhombus. So the sides of a rhombus are congruent, and it just happens that those two sides will match. And then last of all, this one kind of caught me by surprise, but it's totally true. We've been talking about how a rhombus is a parallelogram, right? Well, this line, H to M, is a diagonal, and B happens to bisect. So that creates MB as a half of the diagonal, congruent to HB, the other half of the diagonal. So in a parallelogram, the diagonals bisect, and therefore, these two triangles are actually congruent. After the triangles are congruent, we get to say the angles inside the triangle are congruent by corresponding parts of congruent triangles are congruent. So RBM happens to be exactly the same as RBH. Those two angles in the two triangles are congruent. Now, what does that mean? Well, because they actually happen to be coinciding, they are adjacent, they form a linear pair, and linear pairs are supplementary. That tells us then that their angle measures have to add up to 180, but they're equal. The measure of angle RBM equals the measure of angle RBH by definition of congruent angles. So therefore, we get to swap it out and do some subtraction, and it turns out that they actually happen to be 90 degrees. So therefore, what does that tell us? Well, it tells us the diagonals are perpendicular, because when those those diagonals cross, they end up creating 90-degree angles. Last of all for us in this one, how do you prove the diagonals are actually bisecting the vertex angles? Like those two angles are the same, those two angles are the same, these angles are the same, they're bisected. Well, you use all of what we did from step 1 from up above. So, rewrite it if you want to. But knowing that those two triangles, this triangle and this triangle, are congruent, now tells us that angle HRB, this one, and angle MRB, this one, they're congruent by CP, CTC. And the fact that they're congruent means that the line that, makes this larger angle separate into those two angles, it has to be a bisector. It has to be an angle bisector. So therefore, the diagonals of a rhombus, when they're drawn, they actually bisect the angles at each vertex. And we can use that fact to solve problems. So there you have it, page 405. Activity 1 has a lot to cover. We're still going to continue with activity 1 on the next pages, at least the next 2 pages. So stick around. Let's keep going. Thank you for watching this video. See you in the next one.